welcome to Mega's tutorial. In today's class we are going to study about the optical instruments. So in the video dalella ನಾವು ray optics ಬಗ್ಗೆ ಬಹಳ ಸ್ಟಡಿ ಮಾಡಿದೀವಿ. For example reflection ಸ್ಟಡಿ ಮಾಡಿದೀವಿ, refraction ಮತ್ತೆ scattering of light, and we also derived the expressions for lens makers formula. Then we derived the expression for thin lenses in contact, combination of thin lenses in contact ಮತ್ತು spherical surface. Okay, ಆ ಎಲ್ಲ ವೀಡಿಯೋಸ್ನು ನಾವು ಚಾನಲ್ನಲ್ಲಿ ಅಪ್ಲೋಡ್ ಮಾಡಿದ್ದೀವಿ. ಆ ವಿಡಿಯೋಸ್ ನಿಮಗೆ ಇಷ್ಟ ಆಯ್ತು ಅಂತಂದ್ರೆ ದಯವಿಟ್ಟು ಲೈಕ್ ಮಾಡಿರಿ. ಇವತ್ತಿನ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು ರಿಫ್ರಾಕ್ಟಿಂಗ್ ಟೆಲಿಸ್ಕೋಪ್ ಆರ್ ಟೆಲಿಸ್ಕೋಪ್ಸ್ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಓಕೆ, ಸೊ ವಾಟ್ ಈಸ್ ಅ ಟೆಲಿಸ್ಕೋಪ್? ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಅ ಡಿವೈಸ್ ಯೂಸ್ಡ್ ಟು ಪ್ರೊಡ್ಯೂಸ್ large angular magnification of the distant objects. ಈಗ distant objects, say for example the stars or the planets or the celestial objects which are very far away from the surface of the earth, we can produce large angular magnification of such objects using the different types of telescopes. Out of those different types of telescopes, we are going to study the two telescopes for our syllabus. The first one is refracting telescope. In this refracting telescope, it is having an objective and an eyepiece. This object is having objective, it is having a large focal length and a much larger aperture than the eyepiece. Okay, so light from a distant object enters into the objective, and a real distant object, real distant image is formed at A dash B dash. It is formed in the tube. Okay, and this is formed at the second focal point of the tube. This eyepiece, the eyepiece which is present here, it magnifies this image, producing a final inverted image here. So magnification for this refracting telescope, it is given as m is equal to f0 divided by fe, where f0 is nothing but the focal length of objective and fe is focal length of the eyepiece. Okay, so here f0 means it is the focal length of the objective and fe is the focal length of the eyepiece here. To get larger magnification, the objective of longer focal length and the eyepiece of shorter focal length have to be used here. Okay, then the length of the telescope tube, the length of this telescope tube, it is given by L is equal to f0 plus fe. f0 is nothing but the focal length of the objective and fe is the focal length of eyepiece. L is the tube length. The second type of telescope is the reflecting telescope. It is having the objective mirror here and this is the secondary mirror. So this objective mirror, it is of larger diameter and the light is focused onto the convex mirror, by the concave mirror, right? Then the convex mirror or the secondary mirror which is present here, the convex mirror or the secondary mirror, it focuses the incident light, to the eyepiece through a hole in the objective concave mirror. The advantage of this Cassegrain telescope is its large focal length in the short telescope. Though it is a short telescope, it is having larger focal length. So Cassegrain telescope or reflecting telescope we call it as. These are the two telescopes you have to study for your syllabus. First one is refracting telescope, second one is reflecting telescope. Okay, keep in mind the diagrammatic representations are very necessary. When you draw the ray diagrams, the arrow marks are very compulsory here. If you did not put the arrow marks, then this will not be considered as a valid diagram